Welcome guys to First Farm Integrated Science. Okay guys, so for this week's lesson I have a question for you guys so that you can guess what the topic is. What would happen if your seamstress would just look at you and then sew your uniform? So guys, what will happen if that happens? Would the uniform fit you? What does the seamstress need to do in order for the uniform to fit you best or adequate? If you guessed measure, then you're correct. So this week's topic is measurement. Measurement. We are in week 12 for First Farm Integrated Science from January 18th to the 22nd, 2021. Objectives for this week, guys, is to define measurement, to discuss the importance of measurements in everyday life, to identify the need for making accurate scientific measurements, recognize the need for international agreed standard of unit to represent measurement, which is also known as SI, list the five fundamental quantities along with their basic units, demonstrate the correct use of measuring instruments for common quantities, read the correct unit on the instrument provided. Let's get started. In order to better allow you guys to understand the 7 objectives for this week, we have broken the 7 objectives into different sections. For the following slides, we will be focusing on the following objectives: to define measurement, to discuss the importance of measurement in everyday life. Let's get started on these 2 objectives. Measurement. Measurement is finding a number that shows the size or amount of something. System of measurements. There are 2 main systems of measurements in the world: the metric or the decimal system and the US standard system. In each system, there are different units for measurement, measuring things like volume and mass. What is measurement? It is a technique that compares objects to a standard, fixed without change, meaning that there will be no change in the standard. It comes from the Greek word metron, which means limited portions, provides a quantity, how much of something there is or how many there are. That is what is measurement. Let's continue learning about it. Importance of measurement. It provides structure, prevents chaos that would result from having no method of understanding exact size or amount. Scientists would have difficulty carrying out experiments or forming theories. Measurements show the way we think and interact every day. Why is medication important, guys? For example, taking medication. We need to ensure that our body is getting the correct amount of medication needed. We cannot overdose and we cannot have a low dosage of the medication. In order for our body to fully recover, we need the adequate amount of medication. Cooking and baking, cake, or in general, cooking, we need the correct amount of ingredients in order for that food or item that we're cooking would come out delicious. Other examples of the importance of measurement, guys, is telling time. For example, you would like to know how long it takes to reach from destination A to destination B in order to better prepare for that trip. The fourth example, guys, is transportation. This goes hand in hand with telling time. Since if you are traveling in a general transportation, not your private vehicle, then you would like to know at what time the next transportation is available and what time will you reach your destination. Guys, these are all very important when it comes to measurement. Goals when taking measurement, meaning when we are doing, why we're doing measurement, or how comes we need measurement, is the first thing, guys, we need accuracy. Getting as close as possible to the true measurement of something, the true value. Precision, able to take the same measurement and getting the same result every time. So guys, accuracy and precision go hand in hand. In order for us to have an adequate or correct measurement, we need to have accuracy and precision, guys. The third point is that we minimize error. Never 100% precise or accuracy, but we want to be as close as possible to that measurement that was given. In science, we need to have this, both of these properties, because then we want to get the same exact results every time we repeat this lab. Let's continue, guys. Why do we need to be able to measure things? First thing, what would happen? Any ideas why we would need to measure things, guys? Let's find out. Suppose we want to measure a 2x4 for building a house. Numbers by themselves do not make sense. Our board is 350 long. Long what, guys? We need to know the precise units. A board is meters long. To make sense, all measurements need both a number and a unit. In order for these to go hand in hand and for the individuals to know what he or she is doing. This leads us to the next three objectives. Recognize the need for international agreed standard of unit to represent measurements. To identify the need for making accurate scientific measurements. List the 5 fundamental quantities along with their basic units. System of measurements. The ancient Egyptians' system of measurement was based on body lengths. The cube was the measurement used by the Egyptians to build the pyramids. For example, guys, as you guys can see, the cube would be the arm's length from your fingers to your elbows. Foot span will be the exact same length of your foot. And a hand spade will be from your pointer to your thumb. Now, guys, you have to be very careful, because then remember, we have different people with different foot, different arms, and different hand span. So these will not give you a precise measurement. So this led to the modern system of measurement, which is the most widely used system of measurement, and it's called the metric system. The metric system, guys, is a standard system of measurement. It allows an accurate reading. It was developed in France in the 1790s. Renamed to International System of Units, or the SI system, in 1960. Standardized in almost every country around the world except in the US, which would include units and quarts, etc. All metric units are based on multiples of 10. As a result, you can convert between units easily. In the SI system, each unit of measurement has a basic unit. Remember, guys, SI stands for International System of Units, and it was changed in the 1960s. Let's continue. Basic types of measurements. Length measures distance between objects and is normally measured in meters. Volume measures the amount of space something takes up and is normally in liters for liquids. Mass, measure the amount of matter in an object and is normally measured in grams. Other types of measurements include, you have the time, and we normally will measure it in seconds. You have temperature, which is normally measured in Celsius. You have density, which is normally measured in grams per cubic centimeters. And then you have the pH, which is normally measured by the pH scale. Okay guys, so let's learn a little bit more about length. Remember guys, length is the distance between 2 points. The instrument that we would use in length is a metric ruler, measuring tape or tape measure. Other units for length will be kilometers, which is km for long distance, centimeters, and millimeters, which is short distance. Mass. Mass is the measurement of how much or the amount of matter is in an object. Instrument that we would use particularly in the lab guys is a laboratory balance, which can be a triple beam balance, which is the picture at the top, and then you have an electrical scale, and then the units that we use when measuring is grams or milligrams. Temperature guys is the physical quantity that expresses how hot or how cold it is. The instrument that we use here is called a thermometer. It is measured in Celsius, degrees Celsius, or degrees Fahrenheit. Volume guys. In volume, we will measure the space that an object or substance occupies. We will normally use the measuring cylinder or graduated cylinder. We normally measure, or the unit we measure volume is milliliters. Time. Measurement of period, meaning particularly have to do with time. The instruments that you guys will be using would be a timers, stopwatch, and clock. The units that we normally use guys is minutes, hours, or seconds. To your right guys of the slide, you will see that we have a stopwatch, a clock, and a timer. These three are found in the lab and particularly is used to measure time. The SI unit uses the following prefixes. The system works with any SI measurements. So the following prefix works with any of the standard unit guys. The units becomes whichever type of measurement you are making, meaning if you're using mass, volume, or length, it will become the prefix at the front of the unit that you're doing. For example, kilo stands for 1,000, hecto stands for 10, for 100, deca stands for 10. The unit itself is 1, deci stands for 1/10, centi stands for 100, and milli stands for 1/1,000. It is the same system regardless if you are measuring length, mass, or volume. So whatever you're measuring guys, these prefixes would go in front of the unit, and that will help you to decide the proper value of that measurement. It works for all types of measurement. If you're measuring mass, then it is the gram, so it is in the grams, so then you will have centi or milligrams. If you are measuring length, then it is the meter, which is kilometer, decameter, are examples of how using the prefix. Volume. Then it is the liter, so it will become deciliter, hectoliter. Remember guys, these are prefixes that would go in front of the unit. The first part of the term indicates the amount. The second part indicates the type of measurement that you're using. Centigram. Now guys, we already dealt with 5 of the objectives, so now we will be demonstrating the correct use of measuring instruments for common quantities. We will be reading the correct unit on the instrument provided. So we'll be providing different instruments for you guys to be able to read it. Graduated cylinder or the measuring cylinder. As you guys can see, this would be a liquid in a test tube. Liquid in glass and some plastics containers curve at the edges. Changing the diameter of the cylinder will change the shape of the curve. This curve is called the meniscus. How do you reading the graduated cylinder? Your eye should be leveled with the top of the liquid. For example, as you guys can see in the picture, the curve is demonstrated here. So you will not read it at a low reading or at a high reading. You need to lower your eyes at the length, or sorry, I should say at the level of this curve, which is known as the meniscus. You should read to the bottom of the meniscus. Alright guys, so let's practice reading the measuring cylinder or the graduated cylinder. What is this reading here? So remember guys, when you're reading the measuring cylinder, you would kindly read at the bottom of the curve, which is the meniscus. So please give me the answer for the following graduated cylinder. So let's continue practicing another reading. What is the reading for the following measuring cylinder? Remember guys, you're supposed to read at the bottom of the curve. Try to read as accurate as possible. Remember guys, to calculate the volume of an irregular shaped object by water displacement movement, we would be using the measuring cylinder. Remember to read the measuring cylinder at eye level. You always have to place the measuring cylinder on a flat surface and you would lower yourself to read that measuring cylinder, which is at the bottom of the curve. Now, this particular reading will be for irregular shapes. You fill the graduating cylinder with water, enough to submerge the object, not enough to overflow the measuring cylinder. You would record the initial water level, submerge the object in the water, record the final water level. After you have done this, guys, you will subtract the initial water level from the final water level. The difference is the volume of the object. Now we have an example here, guys. So our initial reading is 155 milliliters. When we place the coin, then our final reading will be 215 milliliters. So we had previously stated that you will subtract the initial reading from the final reading, and then the difference will be the measurement or the volume of that irregular shape. So particularly in this case, guys, once we subtract, we end up with 60 milliliters. So guys, Let's watch a little video on how to read the graduated cylinder. Remember guys that when you're reading the measuring cylinder or the graduated cylinder, you will read at the bottom of the curve of the meniscus. Okay guys, so using the electrical balance, we will be using the electrical balance to measure different weights. The first procedure guys is to press the on button. Wait for the balance to show 0 on the screen. Place the object to be measured on the scale. If we're using a container to hold substance to be measured, then we will place the empty container on the scale and hold the unit button until the screen clears the mass of the empty container. Then we add the substance to be measured, guys. Now, guys, let's learn how to use a triple beam balance. Measuring mass. The triple beam balance would also help us to measure mass. First, guys, we'll place the object on the scale. Secondly, we slide the large weight to the right until the arm drops below the line. Move the rider back one groove. Make sure it locks onto place. So there are grooves here, guys, on the rider that will allow us to measure the particular weight. Now, let's find out what else we need to do. Thirdly, guys, we repeat this process with the top weight. When the arm moves below the line, back it up one groove. Fourthly, guys, we slide a small weight on the front beam until the line matches. We have to there's 3 riders or there's 3 scales, guys. And particularly, we would look at these scales and first we move everything to 0. Then we start with the largest unit, which is 100. Then we go to 10, and then we go to 1 units. So as the second procedure stated, guys, you slide a large weight to the right until the arm drops below the line. And the arm, guys, is what we will be using to get a precise reading, which is circled in red. Then we repeat this process with the top weight when the arm moves below the line, meaning it will drop below it, and then you back it up in one groove. Slide the weight on the front beam unit on the line until the line matches up, until you have a particular matching up of that line, and then that will allow us to add the amount on each beam to find the total mass to the nearest tenth of a gram. Remember guys, we will be using the triple beam balance to find mass of various objects. The objects are placed on the scale, and then you move the weight on the beams until you get the lines on the right side of the scale to match. Remember guys, so you have 3 riders. So once you have placed the scale, you add up the amount on each beam to find the total mass. What would be the mass of the object measures up in the picture. So you'll add the first rider, the second rider, and the total will give you the total mass of the object. So let's watch a video on the triple beam balance. So guys, I hope the little video was helpful in learning how to use the triple beam balance. Things to review, guys. All measurements need a number and a unit. Basic unit of measurements, we will remember meter, liter, and gram. Graduating cylinder, you should read to the bottom of the meniscus. A triple beam balance, the zero marker needs to be at balance in order to get the accurate reading. Reminders, guys. Review the PDF format of the video. View the activities uploaded on Moodle. Kindly do the assessment quiz. Meet the deadlines that are placed on Moodle. Have a great week, guys, and ensure to do as much good posture during this week. To finish this week's lesson, guys, let's listen to a quote by Seth Godin. A useful metric is both accurate in that it measures what it says it measures and aligns with your goals. Do not measure anything unless the data helps you to make a better decision or change your actions. Remember, guys, measurement is very important in whatever we're doing today. Hope you enjoyed this week's lesson and let's discuss it in our virtual meetings.